Okay, so let's implement the filtering algorithm seen right here in NetLogo using the graph coloring problem that we saw before. So you saw this before. We're going to start with just this basic setup here that just draws a random graph and we can lay it out, and that's about it. That's all it does. And so the first thing we need to do, let's go check out our algorithm here. You see these guys, these nodes here, each VI is going to be an agent or a node, and each one has this DI, or DJ actually has this D table. Basically has a list of the domain for all the agents, including itself. So we're going to need that domain list. Let's do that. So notice I have my nodes over there. I'm going to say nodes own domain. So that's the domain. It's going to be the list of all the nodes, and to specify more, item x domain is equal to agent or node as a node x's domain as according to this agent. So yeah, we're just going to use a list for that. So that should be pretty simple. Let's now the thing is, we're gonna need to set this up for all the agents. So I'm gonna write a little new domain method that is gonna report that, and we're gonna need to use n values. How many nodes are there? There are num nodes, and each one is going to be, well, it's simply the list of colors, right? So new domain. This is going to be a reporter. So let's see. That looks good. We have a new domain of all the colors and one for each. Now, one of the things will actually, from because of the way the filtering problem works is, if you have something like this where every node can have, at least 2 values, then we know it's not going to get anywhere, right? So this, the filtering algorithm, the way it's designed, if you have 2 nodes connected by an edge and each one of them can be in any of 2 colors, it can't do anything. And so if we have something like this, it's not going to go anywhere. So let's change these a little bit so that our algorithm can actually do something. So instead of n values, we're going to want some randomness there. We're actually over here, instead of reporting all colors, what I want is n of colors where the number is random in num nodes. I think that's what I want. Let's try that. No. List of length 3. Yeah, is not a random length colors. Is what we want there. Okay, so that's better. Except these ones are 0. I don't want anybody to start at 0. So let's add 1 to it. Oops. Come on. And there, that's better. So I got some of them are 1, 2 colors, 2 colors, 1 or 2 colors. For all of them, some of them 3 colors. 1, 2, or 3 colors. Awesome. So that's my domain. That's going to be my initial domain for this problem. So what I'm going to do is when I'm creating nodes, which is right here, I'm making them circles, setting them, the color is probably, I should just start them out with black. And set domain to be new. Wait, that's not going to work. Then I'm going to create a different one for each one. So I'm going to create just one new domain, and I'm going to set everybody's domain to that domain, the domain. So now everybody starts with the same, whoop, there we go. So as nodes to show domain, and they'll show me, they'll have the same domain. Awesomeness. Okay, what's next? So now everybody's got the domain. That's good. Let's look back at our algorithm. So we're gonna need, everybody's gonna need to go through, everybody is gonna do this filtering, right? So that's the main method. Each agent, each node has to implement the filtering method. So he goes for all his neighbors and revises it. So before I get to that, one other thing is, I'm gonna need, like right now, some of these nodes have 2 colors, some of them have 3 colors that are their possibilities, and I would like to be able to visualize that. So I would like to be able to see that this guy, he could be either red or green or blue or whatever. I actually don't know, so I can do this. I can inspect the node here, and then I would have to go through his domain and find out item 16 in that domain, and that's I'm looking over here. Sorry. I would have to look through his domain, look for number 16, and then match the colors to the numbers. And that's awful. So I would like to be able to just to look at those here. So what I'm thinking is, it would be nice if each node had like some little arrows pointing to other little nodes with the appropriate colors, like little lollipops around him. So let's do that, right? We're gonna call that basically each agent, each node is gonna need. You're gonna write node methods down here, and each node is gonna need those guys. And so basically, we're gonna use more graphs. So I have nodes, and I'm using links here. So I'm gonna, because I'm gonna using also, so I need to change those links to edges. So I'm gonna change my link stuff to use, I'm sorry, this is wrong. This is undirected. I need an undirected link breed, which is edges. And instead of using the built-in link stuff, I'm going to change those to edges. Create edge width. I'm doing this because I'm going to add a second type of link. So when you do that, you need to name both of them. Okay, so let's see, make sure everything still works. So I haven't changed anything so far, functionality wise. So I got those 2, but then I'm going to need some other little nodes just to show the color of each actual possible color of each node. We're going to call those mini nodes. Mini nodes and mini node. And the edges are also undirected link breed. And we'll call those mini links and mini link. Right, so the idea is that these guys are going to connect to each node. So I'm going to need down here, each node is going to spawn his own mini nodes. So 2 spawn mini nodes. And so how is he going to do this? Well, he's going to have one for each color in his domain. So let first I got to get my domain, which is item who in my domain variable. So that's going to give him my domain. And then for each color in my domain, I'm going to need to sprout one of those guys. I think it's called sprout, right? Sprout mini node 1. That checks. Okay. Remember, it has to be sprout or spawn, because it's a turtle is sprout. Patches, it would be spawn. So sprout 1 mini node, and the color of that node, of course, is the key thing, is going to be that. And I'm going to change their shape, so that's not to confuse them with the regular ones, to be square. And what else? I think that's good. Then I need to tie them to, okay, after I sprout that new guy, I need to tie that guy. So I need a hold of him. I'm going to call mini. So I'm going to set mini to self. So I can, now I have that mini variable here, and I can create mini link with mini. So this is going to be called for all the nodes. So after I set them up, I create all the nodes, I connect them, ask nodes to sprout mini nodes. Let's check that. No. Sprout mini nodes. Expected 1 input. Spawn mini nodes. What the? Yeah. Let mini 0. Create. You can't use create mini link with in a patch context. Why is it? Oh, I think that's why I must have used the wrong one here. Let's check the dictionary here. So in turtles, a turtle cannot sprout, right? Can it spawn? Stamp? Sprout? No, a turtle should be able to sprout. Sprout breeds a number. Wait, no. Creates number of new turtles on the current patch. So sprout is not what we want. I think we want hatch. This turtle creates new. Okay, so it's hatch breeds. Yeah, I always get those two confused. Hatch. I guess sprout makes sense because plants sprout from the ground, so this should be used by patches. So hatching is what turtles normally do from their eggs. So okay, so then that's better. So hatch mini nodes, create links. Okay, so let's test this out. So I think now when we hit setup, it's gonna create all those things. We're gonna lay them out. Okay, so that looks good, except these guys are not getting laid out. Our new squares are not getting laid out. So to the layout method, I'm gonna do it again. So layout spring, and the nodes now are the mini nodes, and the edges are the mini edges. And I think I want this smaller. Let's see. Now it's mini links. I change that. Okay, that looks good. They're kind of too far. I would like these guys closer by to. Um, Gotta consult layout. Layout. Radial spring. Spring. So the spring length is the second number. So I did change that to 2. We're gonna make him not as repulsed. Maybe that'll get him closer. Yeah. Okay, so that's better. Maybe a little closer. Okay, so that's looking better. Oh, let's have fewer nodes. Fewer edges. Try it again. That looks good. So this tells us that this guy can be either red or blue. This guy here, red or blue. This guy green. This guy can be green or blue. So those are their domains, their current domains. Those will change as the algorithm runs. So now we have a very nice visualization of the problem. If we do it for even smaller, let me just do a very small one. My brain can't handle that many. I can't really find a solution to that problem. Okay. So this one is smaller, like this guy here, he has to be red. So this guy can be the green or red, but because he's red, I know, and this guy's gonna be green, and then this is gonna be fine. And these are gonna be either red or red and green here. And so yeah, this one will not have a solution because these are red and green. And so okay, this is good. So now let's implement the algorithm. I think this looks nice for now. So the node methods now, going back to the actual algorithm. The filtering method is the main thing that they have to implement. And then, everybody has to call revise. And this is the main loop. So let's do that. To filter. Just saying, for all my neighbors, I'm going to revise myself and him. So for each sort edge neighbors. Edge neighbors is going to be all my edge. It's going to give me all my edge neighbors, and the sort is just needed to turn this into a list because this is an agent set. For each one of those, I am going to do a filter. So this is our node methods that I'm working on. So I'm just going to call, well, I can't call filter. Let's call revise. Revise with him, right? So not much there. So notice to revise with the other guy, other node. So what I'm going to need is my domain and his domain. So okay, what I'm going to do, so what this does is it checks, right? So if there's any, I get my domain, I get his domain, and then I go through each of my possible colors. If given that color, he can't be, there's no color for him to be in, then we remove that color. I remove that color from my domain. Now, because I'm doing graph coloring and I know that all the constraints here are binary, I know that basically all I need to worry about is the fact that him and I could be different colors. Okay, maybe you need to think about that for a second, but that's all we need to worry about, right? Because if I am red, then if I am red and all he can be is red, that's a problem. But if he can be 2 colors, say red and green, then it doesn't matter what color I am, right? Because Even if I can only be red, that's okay because he can be green. Or if I can only be green, that's okay because he can be red. So really the problem is going to be when the domains are of length 1, right? So I'm going to get my domain, which is going to be item who. Let me just again check because I keep forgetting. No, that's right. Oops. Item. So his item is index and then the list. Okay. Item, the index is who and the list is domain. So that's my domain, and let his domain is going to be item who of other node domain, right? So if length of my domain is is 0, then stop, we return. That's going to be a problem, right? So if length of his domain is 0, then we stop. Just some base cases here so we know if either one of those is true, there's nothing I can do. If my domain is 0, his domain is 0, forget it. So if length of his domain, if his domain is equal to 1, or is if his domain is greater than 1, then I think we're if his domain is greater than 1, then it doesn't matter. We can return also, because I cannot reduce my domain because it can be anyone, at least 2 colors. So like I said, that's going to be a problem. So now we're down here at this point. His domain has 1 color. My domain has at least more than 1 color. But basically, because his domain has 1 color, I know that I need to remove that color from my domain, right? That's really the only thing I need to do. So if it is in there, right? So if first of his domain, that's going to be his color. He's only 1 possible color. If that one is a member, again, let me just double check the member, because I always forget what order these things come in. Member, it's usually member, value, and the list, right? So that makes sense. So member, the value, and the list is my domain, right? So if his color is in my domain, that means I gotta remove it. So his color is in my domain, so I must remove it from my domain. And how do I do that? I'm gonna have to set domain to be replace item. Again, I'll look that up. I know it's a replace item, but that one has like 3 arguments. And so it's replace item, index, list, and value. So replace item, the index is who, because it's my domain. The list is domain, so I want to set my domain to a new version of itself, and the new domain is going to be remove, and I'm gonna need I probably should have set this to let his color be first in his domain, and his color. Remove. Okay, again, let's check how remove works. Remove an item from the list returns a new list. Okay, remove the item, which is his color, from the list, which is my domain. So that's going to give him my new domain. And we're going to put that in here. Awesome. So I probably should, yeah. So I do that. I set my domain. If his color is not in my domain, then I don't need to do anything. Okay, so let's go back to our algorithm. And then, so we did this, and this. Now they're saying if the old domain, if my domain did change, then I gotta tell all my neighbors about it. So right here is where we know that the domain changed. So tell my neighbors about it. So my neighbors are gonna be ask, call them edge neighbors. So my neighbors are the edge neighbors. I'm gonna ask them to do this kind of thing, but I need my new domain here. So okay, let my new domain, because I don't want to do this twice. Put this up here. My new domain is that, and then yeah, something like this. Except it's not the who there, right? It's going to be set domain. So this is my edge neighbor. Is not who, but who of myself. So who of myself and my new domain. So this is the part where I ask my neighbors to update their domains of me, like what they think my domain is. Just telling them. I'm just telling them my new domain is this, right? So this is right. We can do this now because when you're building agent-based models in NetLogo, this is nice. One guy can go in and like change another node, another agent variables. However, it works in this case because that's all I'm doing. You gotta be careful because you can't. If you do it this way and you start calling methods on the other guys, that could lead to problems, right? So for a more sophisticated model, you will want to use message queues. Anyway, but I think this will be fine for now. I don't know. So that's revise with the other node. That's my filtering. And I think, let's go back to the algorithm. That's it, right? So that's all I have to do. When I call those guys, and then, that's going to generate a new revise. But what we're going to do is in each go, so to go is going to do ask nodes to filtering, do some filtering. So each time we hit go, we're going to ask all the nodes to do filtering. Right, so each one is going to do a revise with all his neighbors and maybe update all the domains. Now one thing I'm not doing is changing colors in the graphical representation. I'm gonna need an add button here, a go button, sorry. I'm gonna add a go button. So lay it out, see if it crashes. No, we don't see anything because I didn't put any color updates here. So I'm just changing the domains. Right, and so what we need to do is go back and redo this, right? So we're going to redo the visualization. So there's a couple of things I want to do. Each node has this domain here. So now what I want is each node should get his color from his domain and update these guys here. Let's do that first. So at each time through the go, we're going to do that. We're going to ask the nodes to do the filtering, and then after that, I'm going to ask mini nodes to die and ask mini links to die. So I'm going to kill everybody off just so I can build them up again on mini nodes. So yeah, so that's an easy way. Just kill all the nodes and respawn them again, because every time we spawn them, they're going to match our domain, right? So let's try that. If I hit go, yeah, some of them go away. Some of them go away. So you see now, this guy, he can only be one color. He can't be red. This guy, he can't be any colors. So that means there's no solution found. So it looks like it works at this point. So it's just a matter of making it a little bit prettier so they're not black anymore. Like one thing I could do here is spawn mini nodes, and I'm gonna let my domain is going to be item who of domain, and if length of my domain is 1, that means I have only one possible color. Then I'm going to set myself to that color. Set color to be first in my domain, right? So that way it'll look a little bit prettier. And when I hit go, see, this will be green, green, red, red, blue, blue. Nice. We still have black ones are the ones that I have not been able to set. So, this is what happens with the filtering algorithm. Some of them get set, some of them do not, right? So this one just has 2 options. So here's another one example. This guy has 2 options, 2 options. When we hit go, this one still, but these guys now collapse to 1. So we have this partial coloring here, but this guy, he can, they're still undecided now. Since he's blue, I think this guy should now be red, right? I think so. Yeah. So I hit go again, and now he's red. And so the way this works is, keep hitting go. Eventually it's going to stop making progress, and actually rather quickly. I think after 2 goes. But that works, right? So we can see that worked very nicely. We got almost all the solution, and this is undefined because this one can be blue and this one can either be red or green, which is fine. Let's try this again one more time. Go the first time. We got these 2 down here, got their colors set, and this one also, because this one's green. Yeah, I think that's it, right? Not much else we can do. Go again. Yeah, we're stuck there. Okay, so let's look at the code one last time. You see, this is, it's a fairly straightforward implementation from the algorithm of the algorithm. It's a fairly simple algorithm. Now, the main thing you'll notice that we change is, this part doesn't look so much like this part because I took advantage of the fact that we're dealing with just edges. So 2 pairs, this will depend on your application, especially, line 3 here. If there is no value that's consistent with can be implemented in many different ways depending on your application. So when you try to do this for some other application, you'll have to think about that.